So I wanted to do a quick video on the double slit experiment and a little bit about quantum physics. Obviously I'm not an expert, but it's confusing a little bit because you get sort of mixed signals, you know. So first let's just talk about the double slit a little bit. I'll bring it up here. Double slit. You know, I've talked about this before. So basically, if you look right here, I don't know if my face is covering that or not. I don't think it is, but yeah, if you look right here, they shoot, you know, individual particles, and they've done this up, I think, with a carbon-6 molecule. You know, any sort of particle, they'll shoot through one at a time through these two slits, right? And what happens is they get this interference pattern that makes it look like there's a wave, you know, going through the slits and then interfering with itself. And then when they measure it, you know, they put a detector right here to see which slit that goes through. This collapses into just two slits, right? And so there's the observer effect, right? And so some quantum physicists, they say, the observer has an impact on how the particle, the state of the particle, or the location of the particle, right? You could say by observing the phenomena collapses into a definite state, right? And then some quantum physicists who, you know, subscribe to the many worlds theory say, well, you're just getting confused a little bit, you know, because when you measure which slit the particle goes through, the act of measuring interferes with the interference pattern, and it just looks like the observer had the effect, but really it's some mechanical sort of manipulation of the effect by observing it, right? So if you like place an atom behind one of the slits to see which slit that goes through the atom interferes with the wave pattern, and it collapses the wave pattern. And so we should just ignore the observer effect and just focus on the interference pattern, and we can interpret reality, you know, in the context of the interference pattern, and then they come up with these complex theories that leads to, you know, multiple dimensions and many worlds and infinite realities and all this kind of stuff, right? And then, so the thing that's kind of confusing is when you talk to someone who subscribes to the many worlds theory, they'll pretend that the observer effect was debunked, right, or never even existed, and so they always tend to have these sort of smug looks on their faces, like, because they're materialists, right? So the majority of scientists these days subscribe to materialism, right, where there is no there's nothing to consciousness, free will is a delusion, and everything can be broken down into simple sort of mechanical, you know, Newtonian sort of physics, right? And they want to interpret the world in that context, but they tend to reject any information that contradicts that worldview, and so they're sort of stuck, you know. And so if you talk to someone who is a many worlds theorist, they'll say, oh no, people who do these movies like What the Bleep Do We Know and whatever, these crazy New Age sort of documentaries, you know, that theory is based on the observer phenomena, which has been debunked, and it's not true. The wave collapses because of interference, physical interference from observation, right? And it's not that the observer is special. It's just that, you know, it interferes with it physically, and it collapses the wave function, the wave pattern, right? But it's not true. So they're disingenuous because they pretend like all quantum physicists believe that, right? But if you look at this guy, there's a lot of them who don't believe this. They believe that the observer effect is real, and it's proven, and so there's no reason to sort of develop theories like the many worlds theory, because we can just focus on what we observe, the observer effect, right? And so Anton Zillinger is one of these guys. I mean, he's got multiple, you know, awards. You can see all these international, you know, honors and awards, and then some Austrian ones. So he's an Austrian quantum physicist, and he developed quantum teleportation, where he's able to teleport information using qubits or something like that, using like entangled particles over long distances. And yeah, so I think quantum computing is based on his research, quantum teleportation, the quantum information theory, and all that. And so I just wanted to show a little clip here of him talking to the Dalai Lama, right? And so this, I don't think he's a Buddhist. I don't think he's a mysticist or anything like that. You know, he might. I don't know what his religion is. He's probably an atheist. I don't know. And so don't interpret this as he's trying to spout some spiritual sort of stuff, right? He's just trying to explain quantum physics to the Dalai Lama, and it's just this part. I mean, this is a 6. I don't know. It's probably about a couple hours long, this whole thing. But I just wanted to point this one part out. I want to show you this one little part. So just listen. Did I not have that thing plugged in the whole time? Shit. I don't even know if the mic's plugged in, but let's play this anyways.
He has quantum mechanics. And the approach, I will talk later more, but just now in kind of terms of a small overview, is that we are simply asking, maybe knowing, maybe knowledge is as fundamental or maybe even more fundamental than reality.
So maybe knowledge is as fundamental or more fundamental than reality itself, right? And so he's saying this because of the observer effect, because a particle doesn't take on a definite state until it's observed, right? And there has to be a subjective observer in order for reality to sort of have any cohesiveness to it. And so anytime you see these sort of quantum physicists and they're talking about how, you know, the observer effect is just some fundamental, you know, sort of misunderstanding of quantum physics that lay people have, and you can't really interpret, you know, quantum physics to support theories like simulation theory or something like that, right? I mean, the guys they're full of shit. They're being disingenuous. You know, they might think it's not true, but let's not pretend that there aren't, like, you know, award-winning, brilliant quantum physicists that do believe the observer effect is real, right? And so I should have brought this stuff up beforehand, but there's another type of shit, I forgot what it's called. Sort of double slit experiment that proves the observer effect is real. Let's see, double slit backwards causality. Yeah, delayed choice quantum eraser. I've talked about this before on my videos too, but I just want people to understand that just because a physicist gets on, you know, TV and starts talking like the observer effect is completely debunked and never existed in the first place, I mean, the guy's full of shit. He's lying. He's just trying to manipulate people to support his own materialist perspective of reality. So basically, if you look right here, you know, it's very complicated. You can go through and read this thing, but basically, so there's 2 detectors. So there's one here, right, and there's one back here. And so this one is not observed, so there is no detector here. And so you would assume that there would be a wave function there because there's no detector there to interfere with the wave function, right? Here, there is a detector, and there is, I mean, yeah, so there is a measurement taking place at this second detector here, right? So what happens is, I think there's a pair of entangled particles that go through these systems somehow, right? And so you would expect that this one should show a wave pattern and this one should show just the 2 slits, because a wave pattern is going to collapse because of the interference of the observer or the scientific instrument, right? If many worlds theory was true. But what you get is you get the wave, you get this one collapsing into double slits because this one's observed, right? And since the particles are entangled, they share the exact same states. And since they share the exact same states, since this one was observed, this one also collapses, right? There's no reason for this one to collapse along with this one. This should show a wave. This one should show the two slits, right? Because they're two particles going up. And so this one proves, since there's no detector here and you still get the collapse of the wave function, that the observation is what that took place over here is what collapsed the wave function over here, right? And so this proves that it's not just some physical, mechanical interference of observing the two slit that causes the collapse of the wave function, right? And so it's important because it has extremely large implications for our interpretation of reality, right? And I think this really plays into sort of the simulation theory, because if you look at it, reality doesn't collapse into a cohesive state until it's observed, right? And if you look at it from, it even supports like the law of thermodynamics, right? It's because, does it? Am I getting lost here? So, well, it conserves conservation of energy, basically is what it is. I don't know, forget that thermodynamics thing, but like if you look at the reality as a simulation, right, that's run off a processor, in order to save processing power, you're not gonna render the entire image of the universe at once, right? You're only gonna render it as needed. And so, like, you could say, as I turn in my chair, the reality starts collapsing before my eyes as it's needed. But behind me, reality does not collapse because I'm not observing it. You're observing it, though, and so it's there. Well, you're not observing it real time, but... And so you could say, as you look inward, too. And so right now, the outer shell of everything is just collapsed because I can't observe anything on a microscopic scale because I don't have the sense organs, powerful enough to do so. And so to conserve processing power, only the outer shell of everything's collapsed. But as I start looking inward using scientific instruments, then it starts collapsing upon observation, right? And so it supports, sort of this conservation of processing power that you would assume would exist if the reality was a simulation, right? Let's see. And there are like these weird I mean, I talked about these before. I talked about time dilation before, where as you take off at high speeds, time will slow down because there's a lag. There's a computational lag between the observer on Earth and the object moving at high speed. The observer within the high speed object is going to experience time passing as normal, whereas the person who observed from Earth is going to see lag. Just like, in a video game, if you don't have a processor strong enough to render the image at speed, when the character gets in the car and tries to take off, if your processor sucks, you're going to see a lot of lag from your computer screen, right? The outside observer, you're going to see the lag. If you put yourself in the shoes of the character inside the car, time passes as normal, right? And so you can see, you bump up on the limitations of the simulation's processing power in relativity as well, right? So it's not just time that's affected by velocity, it's also length. There's length contraction, right? So, like, say if you had a space this big and there was a stick, an arrow shot through at the speed of light that was actually this long, right? You could... Alright, I'm not explaining right. Basically, as an object moves faster, relative to an observer, it decreases, it contracts in length, right? So if you take a 10-foot object and try to fit it in a 5-foot box, when they're both traveling the same speed, the box and the object, you're not going to be able to split it. But if you move that object towards the speed of light through the box, for a split second, it's going to be able to fit inside the 5-foot box because it contracts in length, right? And so you could see how that would also, if you shrink an object as it's moving faster in speed, you're actually going to save the amount of processing power it takes to render the image of the object moving at velocity. So if you can interpret all these weird stuff in quantum physics and in relativity in the context of computation, a computational system like a simulation or a software or a video game or something like that, and then it makes perfect sense, right? But materialists don't like the idea of the observer, because no matter how you sort of interpret the observer, God damn it, I'm not. Whatever. It's probably still interesting, but the observer's role in reality is initiating the collapse of the cohesiveness or that rendered image or rendered state, right? And so you have to have a conscious, subjective observer in order to do so, right? And so a lot of people say, no, that's not true, blah, blah, blah. Yes, it is. It's true. Quantum physics proves it. I mean, this delayed choice quantum eraser proves that the observer has an effect on the collapse of reality, and that's why Anton Zillinger, one of the most brilliant quantum physicists in the world, says it looks like
as fundamental, or maybe even more fundamental than reality.
So knowledge is just as fundamental or even more fundamental than reality itself. And so the knowledge of something being there is more important to the object being there than any sort of physical system, right? So what else was I going to talk about? Yeah, so these videos can get a little sloppy. I had a point. Let's see. Oh yeah, and then you get people like, where'd it go? God dang it. Or is it on a different one? So you get like, let me keep it on there. I'm probably going to redo this. But you get like philosophers of science talking about how you can't interpret quantum physics at all, right? You only use quantum physics to sort of as a tool to sort of predict where particles are going to be at in mathematics or something like that, and that you're not allowed to take the observer effect and try to apply it in your interpretation of reality, right? And so you get people like Anton Zillinger, who actually does quantum physics, who would completely disagree that you can't interpret reality based on quantum theory. It's just stupid, because what are you trying to do? What are quantum physicists doing? They're trying to understand the nature of reality, right? They're trying to understand what is. It's not just about the fun of doing math. They're trying to figure something out about what this is, what reality is. And to say, oh, you can't use the information that they discover in quantum physics to interpret reality, it's fucking stupid, because all they're saying is that it contradicts their own materialist worldview, right? And so therefore it's against the rules to interpret it, in terms of the nature of reality, because their interpretation is going to contradict their religion, basically, right? So I'm just saying, you can believe whatever you want. I mean, if you want to buy into the many worlds thing, that's fine. I don't, But let's not pretend like the observer effect is a misunderstanding of quantum physics, or there aren't like mainstream brilliant quantum physics who buy into the observer, because it's not true. And I think it's disingenuous how you have a lot of these many world guys, going on television and pretending like, that it's just a layman's misinterpretation of quantum physics. So, well, that was it. That was pretty sloppy, but I hope you got something out of it. I think it was interesting. So thanks for watching. Subscribe, hit that mushroom down there, and I'll see you next time. Bye.